Hello again, welcome to our geometry videos. This is Unit 2, we're on problem number 97. And so we're asked to graph these points. I don't have a graph paper again, but holy cow, you know what, there's a line tool, we should probably use it. Okay, so there's that. Oh no, that's not what I want. And there we go. Is that what I want? That's not what I want. Okay. Let's see. Yeah, there. Okay. So these are just our axes. Those are x and y axis. I'm just going to kind of sketch these points. So 2, 7. So there's 2, 7. We got 4, 8. So 4, 8 is about there. Then we got 4, 2, which is about here. And then 2, 3, which is about here. Okay, now when we connect these points, we get something that looks weird. Get something that looks like that. Which I would say at first glance, I'd say, hey, it looks like a trapezoid, right? So what is the best name for this shape? Justify your conclusion. Okay, well I can justify my conclusion, and that's a trapezoid, because there is one pair of parallel sides. I know these two sides are parallel because going from 2, 3 to 2, 7 is a vertical line. Going from 4, 2 to 4, 8 is a vertical line. So they're parallel. These other two sides, however, are not parallel. Right? Going from 2, 7 to 4, 8, right, that has a vertical slope. And going from 2, 3 to 4, 2, that has a negative slope. So the positive slope and a negative slope, those are obviously not parallel. But the other two sides are. So a quadrilateral in which one pair of sides are parallel gives us a trapezoid. So I would say trapezoid. It says quadrilateral A prime, B prime, C prime, D prime is formed by rotating this 90 degrees clockwise about the origin. Okay, so what this is going to look like is with this cool selection tool. Okay, so we take this and then copy it and paste it. Nice. Okay, so here's our translation, right? We just slide it over, so the translation. So our rotation would be, now we're going to rotate this 90 degrees clockwise, right? And we get that little thing that tells us right when we're at 90 degrees. Okay, perfect. So there's our 90 degree rotation. Now this probably isn't going to fit. Maybe it will. Okay, so match that up with the origin, right? Taking the origin of the rotation, matching that up to the origin of our original. So that's what the picture would look like when we rotate it 90 degrees into the next quadrant. 90 degrees clockwise into the next quadrant. We want to find out the coordinates of these vertices. So the original point here, 2, 7, this was A. So the original point was over 2, up 7. So when we rotate it, now it's over here, this is A prime. Now it's over 7, down 2. So A prime is over 7, down 2. B prime. B prime was 4, 8. So the original B was up there, so this B prime is down here. So if the original B was over 4, up 8, this new B, B prime, is over 8, down 4. Okay. C was this point for count 2, so that means this is C prime. So if the original point was over 4, up 2, this new point C prime is now over 2, down 4. and then d prime, so this was d at 2 comma 3, so that means d prime, instead of, if original d was over 2 up 3, d prime is over 3 down 2. And so we notice there's a relationship here, right? 2, 7 turns into 7, negative 2. 4, 8 turns into 8, negative 4. 4, 2 turns into 2, negative 4. So there's a nice pattern here. What happened is that, the original y value, 7, 8, 2, and 3, became new x values, 7, 8, 2, and 3. And the new y values are just the negative version of the x values, 2, 4, 4, and 2, negative 2, negative 4, negative 4, negative 2. Now there's little tips and tricks for those coordinates for a lot of different things when you're reflecting over the x-axis, reflecting over the y-axis, rotating 90 degrees, rotating 180 degrees, reflecting over a diagonal line. There's all these little tricks as far as what happens to the coordinates of a point and the relationship there. There's way too many for us to go through right now, and you probably wouldn't even want to remember them and memorize them all as of right now. So if you're really interested, maybe we can make another video later on of all the relationships between coordinates and their transformations. But for right now, you can just visualize, use tracing paper, rotate it around, and then count out where the points are going to be from one vertex to the new one. The last thing we're asked to do is find the area of ABCD and show all your work. So to find this area of the trapezoid, I'm going to use the formula for the area of the trapezoid. 1/2 the sum of the bases times the height. So let's figure out. My tablet does not have an angle here, so my writing is all funky. Okay, let's figure out what the bases are and what the height is. Something just bit me in the foot. Ow. Okay. I'll survive. I'm gonna man up, toughen up, finish this video. Okay. Find the area of ABCD. So let's find the bases. So from point D to point A, that's a difference in y from 3 to 7. So that's a distance of 4. The other base here, from C to B, is a distance of 8 to 2, which is a distance of 6. And the height is this horizontal distance from 2 to 4, which is 2. So we have the area equals 1/2. 6 plus 4 is 10, times 2, so we have 1/2 of 10 times 2, 1/2 of 20, which is 10. Okay, I'm going to go pull this bug out of my sock. If you have any questions, please feel free to leave a comment. Otherwise, subscribe, like, or share to our videos.